Hey guys, it's Miss Johnson and I'm here to bring you our fourth video of Unit 1. We are talking about graphing lines in any form today. So our learning target is I can graph and write equations in any form. So the form that we are learning today, so far we've talked about slope-intercept and point-slope form. Today we're going to talk about standard form of an equation. Now that term is kind of deceiving because when you think standard form, you think that it's the one that you use all the time. Well, that's not necessarily the case here. So standard form of an equation looks like this. So we have ax plus by is equal to c. So a, b, and c are just numbers, they're constants. And what happens in standard form is that you have the x term and the y term together on one side of the equation, and on the other side of the equation you have the constant that's alone. Okay. Now the thing about this is a lot of people want to look at this equation and say, oh, a is my slope because it's with the x variable. That is not the case. The coefficient in front of the x variable is only the slope when y is by itself, but y is not by itself here. So this is just merely a form that we use to model situations given two variables. Very often we will use standard form to write an equation. Okay, so it's usually the easiest form to write an equation in. And then typically if we're going to graph them, we just turn them into slope-intercept form. I would subtract my x term over to the other side and then divide by that b coefficient that's in front of the y so that I have y by itself in slope-intercept form and I can graph it. So let's take a look at a few examples. So let's just practice turning these things into standard form. So again, standard form is when I have ax plus by is equal to c. A, b, and c are just numbers. A and b are coefficients, c is a constant. So I want the x and y term together on the left, and I want the constant on the other side. That means that this needs to go over there, this needs to go back there, and that needs to go back there. So that's kind of what's happening in this question. So if I move all of those terms, that means I'm going to have to subtract this 4, and I'm going to subtract it from the constant, which is 9. I also need to add 5x, and I'm going to add 5x to my x term, which is the 6x over here. And then I need to subtract this 2y, subtract 2y over to the other side. Because what that does now is it makes this eliminate from the left, and it makes these two eliminate from the right. And what you're left with is 11x minus 4y is equal to 5. That is standard form. I have the x term on the left with the y term, and I have the constant on the right of the equal sign by itself. X and y together, y by itself, or constant by itself. So, and it is fine to do all of those in one step. Okay, you're combining like terms. I put the x with the x, the y with the y, the constant with the constant, and that's okay. But now when I take a look at number 2, in number 2 I notice that I have some distribution that I have to take care of first. So I have to do that before I can start moving terms. So I have negative 6x minus 5y minus 7 is equal to 8 plus, and now here's the distribution. 2 times 3x is 6x. 2 times negative 7 is negative 14. So now I'm ready to move all that stuff over that I need to. I need to keep my x and y here. I'm going to add the 7 because I don't want a constant with the x and y term. I want my constants on the other side. But we know equation balancing, that means I need to add 7 over here too. So I add a 7 to the constant. Then I need to subtract this 6x. Okay, I'm going to subtract 6x. Now I notice that there's not a y term over here, so the 14 I'm going to have to figure out what to do with that later. But let's just see what this does. So I have negative 6x minus 6x, which is negative 12x. I still have that minus 5y. I haven't done anything to that. And then the 7's are gone, which is what I wanted. On the right, the 6x minus 6x is gone, which is good. And then I have 15 minus 14. Then if I combine those, these are both constants. I can put them together. The negative 12x minus 5y is fine, and 15 minus 14 is 1. So I have x term, y term, constant on the right, and I'm good. Okay. Now, some textbooks and some places will tell you that you have to have a leading coefficient that is positive. We're not too concerned about that here, but just know if you are doing a multiple choice test, you may see this equation distributed with a -1 throughout, because what that'll do is give you a positive 12x plus 5y equals -1, and then that leading coefficient would be positive. I would mark either one of these correct. -12x minus 5y is equal to 1. Both of those are technically in the right order and in the right places and on the right side of the equal sign, so that's fine by me. Just recognize that there may be a -1 throughout, which makes everything its opposite, so that that leading coefficient is positive. All right, so now let's talk about what happens if we are just given 2 points. We want to write an equation in standard form with the 2 points given. Now, here's a little clue for you. The only thing you can do with 2 points is find the slope. Okay, that has to be the first thing that I do. And remember that slope is my m value, which is the difference in y's over the difference in x's. So if I do 1 minus 3 over 2 minus 1, and let me just be clear, that's this 1 minus this 3, and this 2 minus that 1. Y's on the top, x is on the bottom. That's not point and point, even though it looks like it could be. It's y's on the top, x is on the bottom. So y minus 3 is -2. 2 minus 1 is 1, so that's just a -2. So -2 is my slope. Now, what can I do with that? So I used the 2 points, I found the slope. The only thing I can do with points and slope is put it in point slope form. Okay, so I'm going to do that next, point slope form. I'm just going to pick the 1, 3. It doesn't matter which one you choose. And I'm going to drop that in the point slope form. So I'd have y minus 3 is equal to -2 times x minus 1. Now, if you think back to point slope form, we want to put the y value with the y variable, put the x value with the x variable, and the slope is by itself in the middle. So y with y, x with x, slope in the middle. And this is a subtraction and subtraction. So now that I have point slope form, I'm going to move into slope intercept form. Okay, remember my goal is to get to standard, but I have to do some process. I have to process this a little bit before I'm there. So I'm going to distribute this -2. That's y minus 3 is equal to -2x plus 2. Then I'm going to add 3 to both sides to move that constant over, and I have y equals -2x plus 5. And now I can move into standard. So that's my slope-intercept form, but again, I'm trying to get to standard. And to get to standard, that means that this x term needs to come back over here. So I'm going to add 2x to both sides, makes that go away. You have 2x plus y is equal to 5. That is my standard form. So let's just recap that. I had 2 points. I have to start with the slope. That's the only thing I can do with 2 points. Once I have the slope value, I went to point slope form because I can put a point and a slope into point slope. Then from point slope, I moved into slope intercept, and then from slope intercept, I went to standard. So these are all the forms of the equation that we have learned throughout this unit. Let's try that one more time in number 4. So again, in number 4, the only thing I can do with 2 points is find the slope. So that's what I'm going to do first. Find the slope. So again, slope is change in y over change in x. That's -5 minus 3 over 0 minus -4. Put that double negative there. You're subtracting -4. So -5 minus 3 is -8, and 0 minus -4 is plus a positive. That's +4. -8 divided by 4 is -2. Oh, I have a slope of -2 again. Look at that. So now I look back at the points I'm given. Now I could do point slope form with this one, and that would work totally fine. But take a look over here. What helps me over here is the fact that I have an x value of 0. And what that tells me is that this is my y-intercept. Because wherever you have your y-intercept, you know your x value is 0. Now, if I know that that's my y-intercept, I can go straight to slope-intercept form, because I know the slope and I know the y-intercept. So my slope-intercept form looks like this. I have y is equal to -2x minus 5. Okay, so I went straight to slope-intercept form. I got to skip this piece and I went straight to there because I already knew the y-intercept. Now, that doesn't mean you couldn't have done point slope with this one. You would have gotten the same answer. It's just nice to recognize the little shortcuts when we find them. But again, my goal is still to get to standard, so I'm not quite there yet. That means I need to add this 2x. So I have 2x plus y is equal to -5. That is my standard form. Notice, by the way, that even though I wrote this 2x underneath the y, that wasn't because I was combining the x with the y term. That's just to signify that it's going to the other side of the equal sign. But we all know that we can't combine x and y. That's 2x plus y equals -5. All right, so now let's talk about writing some situations in standard form. In number 5, I have the situation you have 10 carrots or $10 to buy carrots and tomatoes for a salad. Tomatoes cost $2 per pound and carrots cost $1.25 per pound. We want to write a standard form equation for this. Okay, standard form. So the first thing I always want to do, and this is going to ring true for many, many units, well, for every unit. When you have a word problem, you've got to figure out what your variables mean. So I'm going to say that x is carrots and that y is tomatoes. Now, you could have switched those variables and that would have been totally fine, as long as you tell me. You have to write them down. If you don't write them down, they have no meaning, and I don't know what you're talking about. So, x is carrots, y is tomatoes. So now what I know is carrots cost $1.25, so I have 1.25x. Tomatoes cost $2, so that's plus $2 times y. That's what you're spending. You're spending a $1.25 for every pound of carrots, X, and $2 for every pound of tomatoes, Y. Add those together. Now, what you know is that you have $10 to buy those two vegetables, so those things are going to be 10 bucks. That's your standard form. X and Y together, constant on the other side, and there you are. In number 6, you're moving into a new house. You can carry 56 pounds at one time. That's a lot of weight. One box of books weighs 18 pounds and a box of clothing weighs 10. So again, you need to tell me what you're looking at. So we need to know number of boxes of books, number of boxes of clothing. So I'm going to say that X is my books and Y is the clothing boxes. I should have said boxes of and boxes of clothing. So what I know is every box of books weighs 18 pounds, so that's 18 times every X. Every box of clothing weighs 10 pounds, so that's plus 10 times Y. The total you can carry is 56, and that is your standard form equation. Okay, now if this were something else like a system of equations that we'll look at in Unit 2, we may use this to actually solve and figure out how many boxes of each type we can carry. But for our purposes today, we're just going to practice writing these things. Okay, so let's flip over to the back. On the back of your notes sheet, now we're going to talk about graphing equations. Top two, pretty easy. They're already in slope-intercept form. You know the y-intercept, you know the slope. I'm just going to put them on the graph. So I go up to +3. Slope is -2/3. Remember that that's your B, that's your M. So -2/3, I go down 2, right 1, 2, 3. I always want to move to the right. The negative really just goes with this top number. It tells me I'm either going up or down, and in this case that means down, but I always move the bottom number to the right. Okay, so down 2, right 1, 2, 3. I like to do that a couple times just so that I can make a nice straight line and connect your points. Number 2, also in slope-intercept form. And I guess this should really be number 8. 7, and that's 8. So I start down at -6. That's my y-intercept B value. So I go down to -6. Then my slope is 1/4. So that's up 1 and over 1, 2, 3, 4. Now I could make another point, but it goes off my coordinate plane a little bit, and that's okay. It still might help me make a nice line. So here's my slope-intercept form line, and there we go. Now let's take a look at number 9. 9 and 10, which is what these should be, 9 and 10 are both in point slope form. Now we don't necessarily know how to graph this, so we're going to put it into slope-intercept form. I think that's our easiest method to graphing is just always get that y by itself. So that means I need to distribute the 2, which gives me y minus 3 is equal to 2x plus 2. And I also want to add 3 to both sides. So I have y is equal to 2x plus 5. And that is my slope-intercept form equation. So if I go up to 5, that's my y-intercept. I need to go up 2 and over 1. So I'm off my coordinate plane a little bit, but remember you can also go the opposite direction. If I go down 2 and back 1, that point will also be on the line. Down 2, back 1. Down 2, back 1. Down 2, back 1. So connect those points with a line. Now, and I just want to make some connection between point-slope form and slope-intercept form. Remember in point-slope form, you're actually putting a point into the equation. If you remember that this is your y value and this is your x value, except that this is plus, meaning it was minus a negative. So that means we had a point here of negative 1 comma 3. So let's just check and make sure that that point is actually on the graph. If I go back 1 and up 3, look, there it is. So that point that is in point slope form is a point that's actually on your line. That's not a coincidence. That's because we went from point slope to slope intercept of the same line. Okay. If I use that same logic in number 10, let's see if I can start with that point rather than going to slope-intercept form and just see what happens. So what that means is my y value was minus negative 4 because I got to this positive here. So my y value is negative 4. That's the y value. Over here, my x value was positive 3. So that means I had a point on the line 3 comma negative 4. Now the slope is still a half. Okay, that's still correct. So let's just see what happens. I'm over 3 and down 1, 2, 3, 4. And then I go up 1 over 2 from there. Count the slope just like you would if you were on the y-axis, or down 1 and back 2, and that should be my line. Now, if I put this equation into slope-intercept form, let's just see if I get a y-intercept of what appears to be, ooh, it looks like we're kind of right between that 5 and 6 there. Let's see if that's what I get. So distribute this 1/2. That gives me y plus 4 is equal to 1/2 x minus 3/2. Oh, that's kind of funny. Subtract your 4, and I have y is equal to 1/2 x. Negative 3/2 minus 4, that's negative 1.5 minus 4, same thing. That would be negative 5.5. So negative 5.5 should be my y-intercept. And check that out, right in between the negative 5 and the negative 6. There it is. So using point-slope form, you can do it either way. If you recognize that this is your x value, this is your y value, make a point, count the slope from there, and you get your line. Okay. Let's take a look at number 11. In number 11, now I have standard form lines. So again, I think the easiest way for us to graph these is just to put them in slope-intercept form. Get that y by itself. So I'm going to subtract the 4x term, which gives me 2y is equal to negative 4x plus 8, and then divide by 2. So I have y is equal to negative 2x plus 4. Sorry if that's kind of hard to read there. Negative 2x plus 4. That's the line I'm going to graph. So I'm up at positive 4 for my y-intercept. Then I go down 2, right 1, down 2, right 1, down 2, right 1. I could keep going if I wanted to. Just as long as you have enough points to give yourself kind of a nice straight line. And I didn't do my line very well. It didn't quite go through that point, but that's what it would look like. Then let's try number 12. Last question. So I want to subtract 6x. And that leaves you with negative 3y. Lots of people want to drop that negative when they get rid of the term in front. But guess what? The negative isn't affecting the 6x. The negative is affecting the 3y. So you have to keep it because you still have the 3y. So 6x is gone. And over here I have negative 6x minus 12. And again, I didn't put those together because they're not like terms. Here I have an x, there I don't. So divide by negative 3. on both sides. I end up with, I'm going to come up here just because I ran out of room, y is equal to negative 6 divided by negative 3 is positive 2. So 2x, and then negative 4 divided by negative 3 is positive 4. 2x plus 4. Negative 12 divided by negative 3. Did I say that right? I hope I did. Anyway, y-intercept. My y-intercept is positive 4. My slope is 2. That's up 2 over 1, or down 2 and back 1. Down 2, back 1. Down 2, back 1. And there's your line. All right, that's going to take us to the end of our notes video for today. Thank you very much for listening. Don't forget to check your note sheet off with Ms. Johnson, and I will see you later.